Hi all, in this session we are going to discuss previous year MCQs from EMI and AC chapters. You know, one of the important units of our syllabus. Previous year MCQs, if you practice it, of course, it will help you to get the concept as well as in what level of questions we have to expect in the upcoming exams. Okay, let's start. The question number 1. The current in a coil of 15 millihenry increases uniformly from 0 to 4 ampere in 0.004 seconds. The EMF induced in the coil will be. So you have to find the induced EMF in a coil. You know, from induced EMF, E is equal to minus N d phi by dt. The most basic equation you have. Induced EMF from Faraday's laws of EMI, we have that one. Now here in this question is given current is changing and its self-inductance is given Henry. 15 millihenry means that's a self-inductance is given, and change in current is given 0 to 4 ampere is given, and duration of time is given. Then EMF in terms of self-inductance and change in current is given by, we have E is equal to the magnitude L into di by dt. Since we know here phi will be equal to L into I. That if you substitute, you get this one, the magnitude. So that equation only, if you substitute it, will be equal to L is given 15 millihenry, so that is 15 into 10 raised to minus 3 into di by dt, change in current by time taken. So change in current is 0 to 4 ampere, so that is 4 divided by duration of time is 0.004 seconds. So I am writing it as 4 into 10 raised to minus 3 seconds. 0.004 second, can put 4 into 10 raised to minus 3 seconds. So L is given 15 millihenry and it is 4 into 10 raised to minus 3. So if you do 4 and 4 cancels, so 10 raised to minus 3 goes up, plus 3 cancels, so it is 15 volts. Answer option is C we can have, so C is the correct answer for this. Hope you got it. EMF induced in a conductor or a coil from Faraday's laws, and here self-inductance also you have to take care. Let's go for the next question. Consider a solenoid of length L and area of cross-section A with fixed number of turns. The self-inductance of the solenoid will increase if. You have a 3-mark question is there to derive self-inductance of a long solenoid. We have this equation for self-inductance as L is equal to mu 0 into N square by L into A. Area of cross-section. Mu 0 is the permeability of free space. N is the total number of turns. L is the length of the coil. And A is the area of cross-section. We have the basic equation for that. Now, this question here, when self-inductance of the solenoid will increase. So L should increase. What all changes will be there? Capital L. Both L and A are increased. Length and area of cross-section increased. No, it won't happen because L is inversely proportional length of the solenoid and directly proportional to area of cross-section. So it is not there. Now B, L is decreased and A is increased. So L, if you decrease, L is decreased, A is increased. Okay, chances are L will increase. Sure. So this can be the option. Now check the other options too. Sometimes more than one correct answers may be there. See, L is increased and A is decreased. No, if A decrease, L will decrease only. So it's not. D, both L and R decrease. So only one and only one correct answer is there. That is B is the correct answer. So self-inductance of a long solenoid L is equal to mu 0 N square by L into A. In this equation is inversely proportional length of the solenoid and directly proportional to cross-sectional area. Hope you got it. Let's go for the next question. Question is the mutual inductance of two coils. So it's regarding mutual inductance. You know, in EMI and AC chapter, EMI we have self-inductance and mutual inductance, two of the major topics of this chapter. So it's regarding mutual inductance of the topic. Of two coils C1 and C2 is 20 millihenry. Mutual inductance M is given. In coil C1, the current changes from 4 ampere to 0 in 0.2 seconds. If the resistance of the coil C2 is 4 ohm, then the charge that flows through it per second will be. So charge you have to find out. Q. You know, in terms of current and time, we have charge Q is equal to I into T. Yes or no? And current I you can find from here. I will be EMF induced by resistance, E by R. So EMF induced, how much is that you have to calculate. Divide by R if you do, you'll get I. Then if you times by time per second is the charge. So how much is I? That is the Q. Shall we check? Okay. So here, in terms of mutual inductance, we have EMF induced E is equal to M into di by dt. The magnitude. M, where M is the mutual inductance. di by dt is rate of change of current or change in current by time taken. So here M is given how much? Millihenry. That's given 20 millihenry is the value. So it is equal to 20 times 10 raised to minus 3. di, change in current. Change in current is 4 ampere to 0 is changes in 0.2 seconds. So 4 is the change. 4 minus 0 is 4. Divided by time is given 0.2 seconds. So I'm putting it as 2 into 10 raised to minus 1. That is E. Now I will be what? E by R we have. So let's see E how much will become. 4 minus 0 is 4 only. 4 by 2 is 2. 2 into 20, that is 40. Into 10 raised to minus 1 is that you take it up. Okay, so it will be 10 raised to minus 2. 40 into 10 raised to minus 2 is EMF induced. Now we have to find what? I. So I will be equal to here. I is equal to E is 40 into 10 raised to minus 2 divided by R. The resistance is given. 4 ohm is given here. So it is 4. So that is 40 by 4 is 10 into 10 raised to minus 2. 10 into 10 raised to minus 2. That is nothing but 0.1 ampere is the current passing through. Now you have to find charge Q. So Q is equal to I into T is given charge flowing through per second is there. Time is 1 second. So I into 1 second, that is given 0.1 into 1. That is 0.1 coulomb will be the answer. So option D is the correct answer for this question we can see. Option D. So my dears, concept is EMF induced due to mutual induction. Current in one coil changes, so nearby coil EMF is induced. That's called mutual induction, you know. E is equal to M into di by dt. So here M is given, mutual inductance is given, millihenry it was, should convert to Henry, then change in current by time taken we done. E we got it. From E we got I is equal to E by R. Then Q we have to find charge I into T. So MCQs 2 or 3 levels questions are there. So please take care about these equations. Hope you got it. Let's go for second question. Question number 4. The average value of the alternating voltage V is equal to 157 volt sine into sine omega t over its first half cycle is. So its average value of AC you have to find out. This question is from alternating current chapter. Average value of AC, the voltage we have to find out. V average is equal to 2 into V0 by pi. In first half cycle, the average value of voltage will be 2 into V0 by pi. So please keep in mind that equation. You know average value, then RMS value we have. VRMS you remember? VRMS is equal to V0 by root 2 we have. Peak value by root 2. So average is 2 into V0 by pi is the answer. Now here see, what is V0? V0 is here. For this equation if you compare, then V0 is 157. So this is equal to 2 into 157 divided by pi. So in terms of, okay, pi is 3.14, you can put it. 2 into 157 is equal to 314 divided by 3.14. 314 divided by 3.14 is nothing but 100. So 100 volt is the average voltage here. V average is 100 volt. So option D is correct answer here. 100 volt is the correct answer. Hope you got it. So here average voltage is equal to 2 times V0 by pi, where V0 is the peak value of the voltage. So from peak value voltage we have two concepts, RMS value as well as average value. In first half cycle average will be 2 V0 by pi. So keep in mind the equation. Let's go for the next question. A circular loop A of radius R carries a current I. So is regarding a circular loop I. Another circular loop B of radius R is equal to R by 20 is placed concentrically in the plane of A. So both have two circles are on same plane it is. So one circle is there and one more circle is there. So two circles are kept in same plane and concentrical. The magnetic flux linked with the loop B is proportional to. So this is loop A and this is loop B. The magnetic flux quotient is, you know magnetic flux phi is equal to B into A. And the maximum will be B into A, we can say. B dot A it is, B A cos theta it is. So B into A will be the maximum value. Where B is the magnetic field in this one. So the loop B, the vector B dot vector A it is magnetic field times area vector. Here loop B is in the magnetic field of A. You know the magnetic field produced at the center of a circular coil A, we can have it is equal to mu 0 into I by 2R. Where R is the radius of A. Is given here, radius of A is how much? R is given, capital R. Okay, into A, area of the second coil, that is pi into R square, R2 square I am calling, R1 is here. So if you substitute the values here, easily you can get, just only asking it's proportional to what. So magnetic flux linked phi is proportional to what? That you have to get it. So here if you do, it is mu 0 I by 2 into R1 is the radius of the first circle, that is capital R, into pi into R2 is capital R by 20, so that is R by 20 the whole square. So R square by 20 square. This R and this square can cancel. So what is remaining there? R is remaining. So phi is proportional to R. Phi is proportional to R. See the options? Yeah, we have the option A is the correct answer for this. So two coils are there, A and B. They are concentric and on same plane they are kept. So magnetic field of A, in that only we are keeping the second coil B. Radius is different. So on what the flux is proportional. So basic concept of the magnetic flux only, the concept. Okay. So let's go for the next question. The figure shows the variation of inductive reactance XL of two ideal inductors of inductance L1 and L2 with angular frequency omega. The value of L1 by L2 is. So, best concept of theory. You know, inductive reactance XL is equal to L into omega. Yes or no? So here, XL is equal to L omega. Omega is the angular frequency and XL is given here. So you can say from this equation, L will be equal to XL by omega. Yes or no? Self-inductance will be inductive reactance by omega. XL by omega. So XL by omega, from this graph of XL and omega, you can find that is nothing but the gradient will be tan theta will be. So L will be tan theta here. Simple idea. So gradient of XL omega graph gives you the tan theta. So here question is the value of L1 by L2 is how much? So we can say L1 by L2 is tan theta 1 by tan theta 2. That is equal to tan theta 1 for L1 is 30 degree. So tan 30 degree by tan theta 2, that is tan 60 degree. You know, tan 30 is equal to 1 by root 3 and tan 60 is how much? Root 3 it is. So that is equal to 1 by root 3 into root 3, that is 1 by 3. So L1 by L2 will be 1 by 3. So option is D is the correct answer here. D is the correct answer, 1 by 3. So the gradient of XL omega graph or the slope of XL omega graph gives you the inductive reactance. And here two graphs are given, L1 and L2. So we found the tan theta, angle is given. So directly got it. Hope you got it? Inductive reactance. And it's an ideal inductor. Hence, of course, L and omega only, the factors on which it depends. Hope you got it? Let's go for the next question. A coil of N turns is placed in a magnetic field B such that B is perpendicular to the plane of the coil. So magnetic field is perpendicular to the plane of the coil means B and area vector will be on same line. So please note it. Regarding flux, you know, B dot A it is. So phi equal to, we have BA cos theta. Here theta will be 0 degree. So simply you can say it is B into A. Magnetic field is perpendicular to the plane of the coil is given. Fine. Now B changes with time as B is equal to B0 cos 2 pi by T into T, where T is time period. The magnitude of EMF induced in the coil will be maximum at. So this magnitude of EMF induced is maximum at what time? That is the question here. Small t you have to find out at what time magnitude will be maximum. So EMF you have to find out. You know EMF E is equal to d phi by dt is given. Only n turns are there, so n d phi by dt. So phi is given. So B is given here and A is there. So here you can say, so this will be equal to n into d phi by dt means d by dt of B into A. That is n into A into dB by dt. So dB by dt, this magnetic field you have to differentiate. That will be equal to n into A is the area of this coil only. So it's given, okay, just A you can keep it, into A is actually the area of the coil will be pi r square. It will be pi r square into dB by dt is a differentiation of this one, that is B0 into cos 2 pi by T into T is there. If you differentiate it, cos, you know, it become minus sign. So it will be, and here will be a negative value will be there. So negative into sine 2 pi T by capital T into this bracket 2 pi by T into T is again a function of time. If you differentiate it, it will become 2 pi by T. Yes or no? So here, if you rearrange the equations, the value will be equal to, this EMF induced will be equal to is equal to, here see, n is a constant, minus and minus gone up, n into pi r square is again a constant into 2 pi by T is again a constant, the total into sine 2 pi T by T is coming. That is E. Now the maximum value of E0 will be when, you know, this sine 2 pi by T, this value should be equal to 1. Yes or no? So that's 1 only when, you know, sine value, sine 90, sine pi by 2 is 1 maximum. So we can say this 2 pi by T into T should be equal to multiple of pi by 2. So to get pi by 2, the values, you can have it, you know, pi by 2, 3 pi by 2, let's going on. So maximum value of sine will be pi by 2. Sine pi by 2 is 1, plus 1 is there. So plus 1 if comes, then it will be coming as, you can have n minus 1, n minus half into pi by 2 will be. If you put it, the values if you substitute for n, then you can get it. So it will be 2n minus 1 by 2 into pi by 2. That will be the value of this one. So if you rearrange it, this pi cancels, then small t will be, you can have it, small t will be 2n minus 1 into capital T by 2 will be. But see the options here, t into nt by h, t equal to nt by 4, t is equal to nt by 2, and t is equal to nt is coming. So we are getting 2n minus 1 into t by 2. It's not there. So in that year, the 2024 one region question it was actually. So this question was awarded was 1 mark to all because it's a wrong answer. So here the option one more is there. None of these is the answer. None of this is satisfying this question. Okay. So here how to found the time. Maximum time is actually the maximum value of EMF. That happens, sine function is coming. So that's happening at the multiple of pi by 2's. Okay, the odd multiple of pi by 2. 1 is there, 1 pi by 2 is there, then 4 pi by, like that is going on. Okay, hope you got it. It's given 1, 2, 3, 4 like that values. Okay, so let's go for the next question. The RMS value of current given by I is equal to I1 cos omega t plus I2 sin omega t is. So, the value of current and voltage is a sinusoidal functions. So, it's maybe both of sine as well as cos. Then, the amplitude I0, if it is given, I0 will be equal to root of I1 square plus I2 square will be I0, the peak value. Grade 11th also you might have gone through. If two functions, sine as well as cos comes, then amplitude or the maximum value is given by root of I1 square plus I2 square. Or root of a square plus b square, like that equations you done for a wave equations like. Similar concept I0. Now, RMS value of current you have to find out. RMS value of current, IRMS is equal to I0 by root 2. Basic equation of IRMS. Similarly, VRMS we have V0 by root 2. So here I0 by root 2 we have. I0 is this much. So root of I1 square plus I2 square by root 2 is the equation. IRMS. Root means square value of current. So here will be root of I1 square. So I1 square by, okay, root is coming this way. C is the correct answer for here. Question number 8 will be this. C is the correct answer. Root of I1 square plus I2 square by root 2. Have I got it? So I0 I have to find out. Then I0 by root 2 gives the RMS value. Let's go for the next question. Two coils are placed near each other. When the current in one coil is changed at the rate of 5 ampere per second, an EMF of 2 millivolt is induced in the other. The mutual inductance of the two coils is. So, it again concept of mutual inductance you have to use it. The EMF induced due to mutual induction is E is equal to M into di by dt. So, here M you have to find out. M is equal to E divided by di by dt. So here EMF induced is how much is given? 2 millivolt. So 2 into 10 raised to minus 3 by di by dt. Rate of change of current is given 5 ampere per second. So that is 5. So 2 by 5, that is 0.4 into 10 raised to minus 3. Mutual inductance is Henry. So 0.4 into 10 raised to minus 3 Henry is the answer. Now check the options. Yeah, 0.4 millihenry is there. So 10 to the minus 3 means milli only. So option is A, 0.4 millihenry. Basic concept of mutual inductance only. M is equal to E by di by dt. You might remember the definition of mutual inductance. Mutual inductance is the EMF induced per unit rate of change of current in the nearby coil. Mutual inductance is the EMF induced in a coil due to unit rate of change of current in the nearby coil. In that concept you can get it. So M is equal to 0.4 into 10 to the minus 3 Henry. That is 0.4 millihenry is the correct answer. Let's go for the next. An AC voltage is applied across an ideal inductor. So AC voltage is applied along inductor. The current in it. So, if you apply a voltage, AC voltage across an inductor, then AC voltage across capacitor, AC voltage across resistor, L, C, R. These three components differently much studied. So, in the inductor, current always lags by the voltage by phase difference of pi by 2. Yes or no? And in capacitor, current is leading the voltage by pi by 2. Phase angle of pi by 2. Across resistor, both are in same phase or the phase difference is 0 degree. That idea you have. So here, check the options. Leads the voltage by 1 by 4th cycle, lags the voltage by 1 by 4 cycle, leads the voltage by 1 by 2 cycle. So it's terms of cycle it is given. Okay. So here, pi by 2 degree farad. In that, pi by 2 radian, it's lagging, So it's lag by pi. Lag means half cycle is there. So pi by 2 means 1 by 4th of a cycle will be there. So it lags by 1 by 4th of a cycle. One AC cycle means, it is like this way. So that's the time period is 2 pi. Yes or no? So here is pi comes, here is pi by 2 comes. So pi by 2 means will be 1 by 4th of a cycle will be. Okay. Here's the next question. A coil of area of cross-section 0.5 meters square is placed in a magnetic field acting normally to its plane. So, area is given here and is kept in a plane normal to this one. Okay, so cos theta, that is 0 degree only. The field varies as B is equal to 0.5 t square plus 2t. Where B is in Tesla and T is in seconds. So SI system is there. The EMF induced in the coil at T is equal to 1 second is. So basic concept only. You have EMF E is equal to the magnitude only, the direction. That is equal to d phi by dt. And d phi by dt, of course. Negative sign is there. So here coil is given. So not mentioned number of turns. So it's 1 only. Now that is phi. We have B into A is there for phi. Here A is constant and B is variable. So this you can simplify as E is equal to A into dB by dt. A into dB by dt. So rate of change of magnetic field you have to find out. So it's given here dB by dt is equal to 0.5 t square plus 2t is there. So that is 2 into 0.5 t plus 2 into t is there, that is 2. The differentiation if you do it. So that is 2 into 0.5, that is 1. 1 into t plus 2 is dB by dt. dB by dt is t plus 2. So here A is how much? Area of cross section is 0.5 meter square. So 0.5 into dB by dt is t plus 2. Then at t is equal to 1 second, it is 1 plus 2, that is 3. So when t is equal to 1, it gives at t is equal to 1, dB by dt is equal to 1 plus 2, that is 3 Tesla per second, that is. So 0.5 into 3, that is 1.5 volt will be the answer. That is option C is the correct answer here. So to find EMF induced, d phi by dt is a basic equation. In that phi, sometimes the magnetic field will vary, or sometimes the area may be varying. Sometimes the angle may be varying. Be a cos theta is there, no? Cos theta 2 minus cos theta 1. That also angle variation may be there, area variation may be there, and magnetic field variation may be there. So here is kept perpendicular is given, so angle is fixed. Area of cross section also given, that's also fixed. Now B as a function of time given, so that you have to differentiate. Accordingly, you will get the dB by dt. Hope you got it. Then time is given there 1 second, so substituted, we got 1.5 volt answer. So C is the correct answer. So please follow these questions well, because these all are the last year's questions, 2024 and 23 questions they are there. So please do it well. You can get the score more, and what level of question is coming, that also you can inform. So let's go for the next question. The mutual inductance of two coils in a given orientation is 50 millihenry. If the current in one of the coil changes as I is equal to 1.0 into sine 100 pi t plus pi by 3 ampere, the peak value of EMF induced in the other coil will be. So the peak value of EMF you have to find out in the other coil. That's the question. So here EMF E is equal to, we have M into di by dt, the basic equation, the magnitude, d by dt you have to do it. So M is how much? Is given 50 millihenry. So that is 50 times 10 raised to minus 3 times di by dt. You have to differentiate this. So I is 1 into sine will become cos 100 pi t plus pi by 3 into 100 pi t is again a function of time. So function rule you have to apply. You have to differentiate it. It's become 100 pi. 100 pi is there. Okay. So here, if you differentiate it, this is the value we are getting. So E is equal to, M is given 50. So 50 times there. Then cos value is there, 100 pi is there. Maximum value of cos is how much? 1. So this value become 1. Then it will be the maximum. So E0, maximum value will be equal to 50 times 10 raised to minus 3 times 100 times pi. So 100 is 10 raised to 2. Minus 1 is there. So it will be, and so will be equal to 5 pi will be the answer. 50 into 10 raised to minus 3 is 5 into 10 raised to minus 2, then plus 10 raised to 2 is there, cancel, then 5 into pi, 5 pi is there. Yes or no? It's fine. So it is 5 into 10 raised to minus 2 into 10 raised to plus 2 into pi, that is 5 pi. So option B is the correct answer here for the 12th question. Hope you got it? di by dt differentiation. So sine will become cos. Its maximum value is asking, so that's 1. Total angle. Okay, cos 0 become 1, So the maximum value is 1. Then 1 into this much value. That's a peak value of voltage. That's the concept. Okay. Here is the question 13. A circular coil of radius 8 cm and 40 turns is rotated about its vertical diameter with an angular speed of 25 by pi radian per second in a uniform horizontal magnetic field of magnitude 3 times 10 raised to minus 2 Tesla. The maximum EMF induced in the coil is. So here you have to find the maximum EMF. The peak value of EMF you have to find out. So it's actually when you rotate a coil in a magnetic field, an EMF is induced. This is the principle of AC generator, So the peak value of EMF induced in an AC generator E0 is equal to NBA omega. So just direct multiplication only. N is given, B is given, A is given, and omega is given. So it will be equal to N how much? We have number of turns 40 into B how much? Magnetic field is given 3 into 10 raised to minus 2 into A, area of cross section. So centimeter radius is given. So pi r square is there. So 3.14 into r is 8 centimeter. So 8 into 10 raised to minus 2 the square times omega, the angular radius. So that is 25 by pi is given. So here this 3.14 and pi you can cancel it. Remaining 40 times 3 into 10 raised to minus 2 times 25 times 8 into 10 raised to minus 2 square is 0. So 25 into 4 is 100, So 1000 you are getting here. 10 raised to 3 is 0. So it cancels. 10 raised to 1 comes. Then 10 raised to minus 2 square is 10 raised to minus 4. If you cancel it, the final answer you will be getting as C, 0.19 volt it is. 0.19 volt will be the answer. Okay, so direct substitution only and multiply it. May I go to the next question? The figure shows a rectangular conductor PSRQ in which movable MPQ, this PQ is movable, has resistance R. It has resistance R and resistance of PSRQ is negligible. The arm is negligible. Only PQ have the resistance small r. The magnitude of EMF induced when PQ is moved with a velocity V does not depend upon. See, does not depend upon. So it's a motional EMF. One concept you have. BLV. You know the equation? So motional EMF is that EMF do not depend upon. Magnetic field B, of course it depends. Velocity V, it depends. Resistance R and length. So BLV is the EMF induced. We have. So BLV, 3 functions are there, and on resistance it do not depend. So does not depend upon the resistance R. EMF does not depend upon the resistance. But current I, if you say, then EMF by resistance is EMF do not depend upon the resistance, we can say. B, L and V only, it depends. So direct question, hope you understood it. Motional EMF is the concept. Let's go for the next question. In the process of charging a capacitor, the current produced between the plates of the capacitor is. So current produced between the plates of a capacitor is actually mix of this AC and EMFs, we can say. So here in EMFs you done in a capacitor charging between the plates of a capacitor, there is a variation of electric field. Because of changing electric field, a current is induced, and that is called displacement current, And that equation is of epsilon 0 d phi E by dt. So C is the correct answer there. So this part you can have in EM waves also. Let's consider. Let's move to the next question. Two identical circular coaxial coils A and B. So two coils are there, A and B, arranged in vertical planes perpendicular to each other, carry currents in the same direction. So they have same direction current is there. If the distance between the coil is decreased, distance is decreased between the coils at a constant rate, then the current what happens? So here, in this current concept, we can say, if the distance between the coil is decreased, actually the flux change or the flux passing through the other will be decreased. If flux is decreased, of course, the EMF induced also will be decreased. So the current will be decreasing. So it will be decreasing in both A and B. So flux change won't pass through exactly. So the same theory concept we can say the current will decrease in both A and B if the distance is decreased. So theory question it is. Let's go to the next one. An inductor, a capacitor and a resistor are connected in series across an AC source of voltage V. If the frequency of source is decreased gradually, frequency of the source is decreased gradually, the reactance of, so we have resistance, inductor, capacitor and resistor, LCR series circuit it is. So here reactance of inductor and capacitor is the questions. You know, XC, the capacitive reactance is equal to 1 by C omega. And the inductive reactance XL is equal to L omega we have. Now, if source frequency F is decreased, then omega also will be decreased. If omega decreases, we know here it is directly proportional. Omega decreases, XL will decrease. Here now it is inversely proportional. So if omega is decreased, XC will increase. XC will increase. So here, see, so for inductor, this will be decreasing and for capacitor will be increases. Option A, check. Both the inductor and capacitor decreases. No. Inductor it decreases, XL decreases and capacitor it increases. Of course, it can be the answer. Check the other options too if more than one correct answer is there. Both the inductor and capacitor increases. No. Inductor increases, capacitor. No. So only B is correct answer here. So option B is the correct answer here. For inductor it decreases and for capacitor it increases because XC is inversely proportional to the frequency and XL is directly proportional to the frequency. Hope you got it? Let's go for the next question. A voltage signal is described by V is equal to V0 for 0 less than or equal to T less than or equal to T by 2. So half of the cycle V0 is given. And it is equal to 0 for T by 2 less than or equal to T. So second half it is T. Then for this cycle RMS value will be what? So RMS value of voltage, you know, the peak value is V0 is given there. So we have V RMS is equal to V0 by root 2. That's RMS value. So of course here concept is A is the correct answer. That is given V0 by root 2. So V0 is the peak value of this V. Okay. So V0 by root 2 is the correct answer. The next question. An AC voltage V is equal to V0 sin omega T is applied to a series combination of a resistor R and an element X. So there is two concepts there. One is resistance and another we don't know what is it. Suppose X is there. Like that, two in series they are connected. The instantaneous current in the circuit is I is equal to I0 sin omega T, 10 sin omega T plus pi by 4. So current is sin omega T plus pi by 4. That means current is leading the voltage. Current is leading the voltage. We know in a series circuit LCR across resistance, current and voltage are in same phase. Across inductor, current is lagging behind the voltage. And across capacitor, current is leading the voltage. So here R and one component is there and the net current is leading the voltage. So current leads means that component should be capacitor. So out of the option G, therefore we can confirm which option is there, which element is there. So here X is a capacitor, A may be the answer. X is a negative, no, B is not answer, C is not the answer and A or D can be the answer. Now one more thing is asking XC how much? Inductive capacitive reactance how much? That we have to find out. So here is given this much, then which of the following is correct? So we know the total resistance Z will be equal to root of R square plus X square. It will be root of R square plus XC square because we identified this capacitor. Okay, so here Z will be what? So in these cases is given XC, how much you have to find out. Okay, they are in series is given. Okay, so same current will pass through it. In series current I is given this much. So omega t plus pi by 4 is there. So phase difference is pi by 4 is equal to phi. So can you say what will be tan phi? So if you do the resistance, it is V across R. The impedance triangle if you do, that is VR is given. Okay, and this capacitance. So current will be across the same phase here, and capacitance is pi by 4. Is it? So current is leading by pi by 4 means voltage of the capacitor will be lagging by pi by 4. So we can say this will be VC. It will be by pi by 4. It is done. So in this equation, if you do tan pi by 4 is equal to how much? Tan pi by 4 will be opposite by this one. So it will be become as VC by VR. Tan pi by 4 will be. Then tan pi by 4 means tan 45. That is 1, you know. So we can say VC is equal to VR. VC is equal to VR. So that gives that both voltage are same. So R is equal to XC. I into XC is equal to I into R. So we can say R equal to XC, we can say in this one. Because the phase difference is pi by 4. So tan pi by 4 is VC by VR. So here R is equal to XC we can get. Now if R is XC, both here you can say Z is equal to, you can say from this equation, root of R square plus XC square is there. So that is root 2 into R square. Both are same. So that will be root 2 times R will be the net impedance. Okay. So here it's given XC also will be root 2 times R. It's getting. So concept is A is the correct answer. Hope you got it. So next question, let's see. The direction of induced current in the loop ABC is the direction of induced current. So here you know a loop is the ABC and a current carrying conductor is nearby kept. Current is moving along this direction. Towards right, current is increasing, current is moving. So along ABC, you know the Lenz's rule and Faraday's law. The two, we have the equation E is equal to minus N d phi by dt. The negative sign shows that the direction of induced current will be in such a way that it opposes the change in magnetic field. So if current is increasing from left to right, then this induced current should be clockwise in order to oppose this increase. So clockwise means it should be ABC. So the current should be along ABC if I increases. ABC should be it increasing. So induced current should oppose across this side. Got it? You have this, if north pole is bringing towards, then opposite should be a north pole again. So anti-clockwise is there. If it is taken out, clockwise is there. Like that logic you have now. So here clockwise should be there if I is increasing. The magnetic field is increasing there. To oppose that one, it should be in a clockwise direction. Hope you got it. Let's go to the next question. A square-shaped coil of side 10 centimeter. A square-shaped coil is side 10 centimeter. Having 100 turns is placed perpendicular to a magnetic field, which is increasing at 1 Tesla per second. The induced EMF in the coil is. So induced EMF only. We have the equation E is equal to N d phi by dt. The magnitude N d phi by dt. Now phi we have is equal to B into A. So here side of the coil is given 10 centimeters is given. A square loop it is. So area we can find out. Then number of turns is given. The magnetic field is changing at 1 Tesla per second. So this equation can be N into A into dB by dt. dB by dt will be the equation. So because magnetic field is changing. So N is, we have 100 turns. So 100 times. A, the area of the loop 10 centimeters is there. So it will be 10 into 10 raised to minus 2 meter times 10 into 10 raised to minus 2 L square times dB by dt is 1 only. So it's 1 is equal to 10 into 10 is 100. Okay, 10 to minus 2 got cancels. So it will be like 10 into 10, 100 is there, 10 minus 2 cancels. Then 10 power 2 into 10 minus 2 is there, is again 1. 1 into 1 is 1 volt. So answer is 1 volt here. The correct option is D, 1 volt. Hope you got it. So here, direct question only N d phi by dt. So the magnetic field is changing instead of area. So A into dB by dt will be the correct answer. Let's go to the next question. Which of the following statements about a series LCR circuit connected to an AC source is correct? So about LCR series circuit is the question. Option A. So 4 statements are given. Which is the correct answer? You have to check it. If the frequency of the source is increased, omega increases. The impedance of the circuit first decreases and then increases. First decreases, then increases the question. You know, the impedance Z is equal to root of R square plus XC minus XL the whole square. So if you plot the graph between XC and XL, you will be remember it for this omega is there. Then if you plot XL here, it will be like straight line. Then if you plot XC here, then it will be a decreasing graph. So in the first case, omega increases, the XC decrease and XL increases. XC decrease and XL increases. Then second half, what happens? XL is going on now. So this difference, XL is greater than XC. First is XC is greater than XL. So this logic will be what happens? XC minus X will be positive in first cases. Okay, then after that it becomes negative. Means that gap at a particular time both will be equal also. So it becomes 0. So first positive value 0, then negative value is coming there. That means initially it decreases, become to 0, then increases other way. So we can say about what? The impedance of the circuit first decrease, then increases. Let be there. Next case. If the net reactance XL minus XC of the circuit becomes equal to its resistance, XL minus XC becomes equal to its resistance, then the current leads the voltage by 45 degree. Current leads the voltage by 45 degrees given. So XL minus XC equal to R is given. XL minus XC equal to R means what? If it comes both, no? So here, then tan theta will be pi by 4. So now we have tan phi is equal to XL minus XC by R. If XL minus XC and R both are equal, then tan phi equal to 1 and phi will be pi by 4. So this is exact correct. 45 degree. Now third option 3, C check. At resonance, the voltage drop across the inductor is more than that across the capacitor. No, at resonance, you know, inductive reactance and capacitive reactance both are equal. So in series circuit, same voltage will be there. D. At resonance, the voltage drop across the capacitor is more than that of the inductor. No, both are same only. So option B is more correct here. That's the exact one. So XL minus XC becomes equal then to R. So XL minus XC by R will be 1. So tan phi is equal to 1. So phi is equal to, you will get tan inverse 1, that is equal to pi by 4. Tan 45 degree is 1 degree. So pi by 4. You got the answer? Okay. So resonance concept also you have to keep in mind. In LCR series circuit, if inductive reactance becomes equal to capacitive reactance, then the net impedance will be equal to resistance only. And the phase difference phi between this XL and XC is equal, no? So phi will be how much? 0 will be phi at resonance. So that occurs. And maximum value of current, that means peak value of current will be the maximum. I0 become the maximum in that cases. Series LCR circuit. So resonance frequency, keep in mind. Okay. Next question. An ideal inductor is connected across an AC source of voltage V. The current in the circuit, so inductor is connected and inductor ideal is connected. AC voltage is given, so the current in the circuit is ahead of the voltage by pi, lags voltage by pi, is ahead of voltage by pi by 2, lags voltage in phase by pi by 2. So direct question it is, if inductor is there, it leads, the current will be lagging behind the voltage by pi by 2, or voltage leads the current by pi by 2. You remember the phase difference there. So if this is I, then this will be voltage across inductor. So it will be I will be lagging behind voltage across the inductor. So here is given, current will be lags by pi by 2. D is the correct answer. So direct theory question it is. And what about capacitor? In capacitor, voltage will be lagging behind current, or current will be leading the capacitor. So this will be VC. Current will be leading by voltage by pi by 2. Here will be lagging. Hope you got it. And across resistor will be same phase. VR will be across it. Same phase will be across resistor. The phasor diagram based on that you can do it. Okay. Let's go for the next question. What is the ratio of inductive and capacitive reactance in an AC circuit? Inductive and capacitive reactance in an AC circuit. So inductive reactance we have XL is equal to L omega. And capacitive reactance we have XC is equal to 1 by C omega. So it's ratio they're asking for. So ratio means XL by XC is equal to L omega by 1 by C omega. That is L into omega into C omega is there. So that is omega square into CL, or L into C. So check the omega square LC is the correct answer. So option A is the correct answer here. So direct inductive reactance and capacitive reactance is the concept of the behind it. We got many questions regarding this. Okay, hope you understood it clearly. Next question, see. The reactance of a capacitor of capacitance C connected to an AC source of frequency omega is X. So reactance is given X. If the capacitance is doubled and the frequency of the source is tripled, frequency is tripled and capacitance is doubled, then reactance will become how much? So we have just now we got it, XC is equal to 1 by C omega. So it's given here, new capacitance is 2 times C and new frequency is 3 times omega. So frequency is tripled. So frequency of source tripled means of course angular frequency also will be tripled, because we know omega is equal to 2 pi into nu. So nu tripled means omega also tripled. Now what will be the nu? Of course both are inversely proportional now. So XC dash will be 1 by 2C times 3 omega, that is 1 by 6 times XC. So it will become 1 by 6 of this one. So answer is X by 6 is the correct answer here. Option A will be correct here. X by 6. Okay, so here both capacitance and angular frequency or frequency of the source is inversely proportional to capacitive reactance. That's the concept here. Now, if the same is for the inductor, what happens now? It becomes 6 times, increases, both are directly proportional, L and omega. So here it is inversely proportional, so 1 by 6 will be. Next question, let's see. A square-shaped coil of side 10 centimeter having 100 turns is placed perpendicular to a magnetic field which is increasing at 1 Tesla per second. The induced EMF in the coil is, so induced EMF we know, EMF is equal to N d phi by dt. N d phi by dt is the induced EMF. Here N is given 100 and area is given. So side is given 10 centimeter. So if you find the area, of course you can find it. Then magnetic field is changing. So this equation will be Na into dB by dt. So that will be 100 is there. So that is 10 times 2 times. Area is there, 10 centimeter is there. So 10 into 10 raised to minus 2 the whole square will be there. dB by dt is given 1 Tesla per second. So if you solve it, it will become 10 square into 10 raised to minus 4. So it's 10 to minus 2 into 10 raised to 2. That is 1. Then 1 into 1, that's 1. So answer is D, the correct answer. Option D is the correct answer here. Direct substitution only. Let's go for the next one. A coil of area 100 centimeters square is kept at an angle of 30 degree with a magnetic field of 10 raised to minus 1 Tesla. So B is given. Then the magnetic field is reduced to 0 in 10 raised to minus 4 seconds. The induced EMF in the coil is. So again, induced EMF, we have E is equal to N d phi by dt. So here in phase change, if you find it, you know phi is equal to BA cos theta. BA cos theta is phi. Now B is given changing. So A is given area of the coil, 100 centimeters square is given. Then cos theta, see, they kept at an angle of 30 degree with the magnetic field. So angle between this magnetic field and area vector is 30 degrees given. So it will be phi. So d phi by dt will be dB by dt times A times cos theta. dB by dt times A times cos theta. So it will be equal to, what is dB by dt? It changes to 0 in 10 raised to. So magnetic field is given 10 raised to minus 1 Tesla first, then becomes 0 in 10 raised to minus 4 seconds. So dB by dt will be actually 10 raised to minus 1 minus 0 divided by 10 raised to minus 4. So change in Tesla, so change in magnetic field by time taken into area is given 100 centimeter square. So that is 100 into centimeter square is there, should convert to meter square, that is 10 to minus 4. Centimeter square to meter square, I have to convert it. Then is given cos theta, cos 30, you know, cos 30 is how much? Root 30 by 2. Root 3 by 2 is there, cos 30 degree. Okay, so that is d phi by dt. Now n is given, number of turns is given to, yeah, this area only given is there, so n is 1 only connect. So induced EMF will be, if you solve it 1, this will become equal to 10 raised to minus 1 is there by 10 raised to minus 4. So it will become 10 raised to minus 3 down plus 3. 10 raised to 3 into 10 raised to 2. 10 raised to 5 is there, 10 raised to 5 and 10 raised to minus 4. If you cancel it, it will become 10 raised to 1, that is 5. 5 root 3 will be the equation. A is the correct answer for this. Okay, so if you solve this one, become 5 root 3. So that will become 10 root 3 by 2, that is 5 root 3 will be. Is that clear? So 10 raised to 2, 10 raised to minus 4, it become 10 raised to minus 2 into 10 raised to minus 1, 10 raised to minus 3 is there. So 10 raised to minus 4 comes up, become 10. So 10 by root 2. So 5 root 3 is the correct answer. It's fine. That concept is there. So here again, magnetic field is changing, but angle is there. So you have to consider that one. Let's go for the next question. The current in the primary coil of a pair of coils changes from 7 ampere to 3 ampere in 0.04 seconds. The mutual inductance between the two coils is 0.5 Henry. So mutual inductance is given and change in current is given by time taken. The induced EMF in the secondary coil, we have E is equal to, the induced EMF is equal to M times di by dt. So mutual inductance times di by dt, change in current by time taken. If you do it, M is given how much? 0.5 Henry. So I'm putting it 5 into 10 raised to minus 1 times by di, change in current is 7 ampere to 3 ampere is moving. So 7 minus 3, that is 4 ampere divided by time taken is given 0.04 seconds. 0.04 seconds it is. So this 0.04 I'm writing it as, this will become 4 times 10 raised to minus 2. So this 4 cancels, this goes up, 10 raised to 2 comes, 10 raised to minus 1 is 1. So it will be, answer will be 50. So it will be 50 volt is the correct answer. So option our A is the correct answer here. Let's move to the next question. The self-inductance of a solenoid of 600 turns is 108 millihenry. The self-inductance of a coil having 500 turns with the same length, the same radius and the same medium will be what? So self-inductance and the concept is there. We know the self-inductance L is equal to mu 0 times N square by L into A. So we have L is proportional to N square. Self-inductance is directly proportional to N square it is. So we can say in this idea, L1 by L2 will be equal to N1 by N2 the whole square. So number of turns only difference is there. Remaining area of cross-section, length and medium everything is same. So if you do it, L1 is given here 108 millihenry, so minus 3 by L2 we have to find out equal to N1 is given 600 by L2 is given 500 the whole square. So if you cut short it, L2 is equal to, this 2 zeros cancels, 6 by 5 square is there. So it will be 5 by 6 the whole square times 108 into 10 raised to minus 3. So if you solve into, this will become almost 75 into 10 raised to minus 3. So the answer here, it is 75 millihenry. Here self-inductance is directly proportional number of square if both coils have same area of cross-section, same length and same medium. So it's a concept here. Okay, let's move to the next question. In the four regions 1, 2, 3 and 4, the electric fields are described as. Region 1 Ex is E0 sine kz minus omega t. Region 2 is Ex equal to E0. Region 3 Ex is E0 sine kz. Region 4 Ex equal to E0 cos kz. So region 2, 3 and 4, they all are constant electric field. Only one it is variable with the absolute time t. The displacement current will exist in the region. Of course, displacement current we have is a ratio of rate of change of electric field actually causes the displacement current. So only region 1 it is there. The same topic will be there in AC. I mean this EM waves, displacement current concept also. So rate of change of electric field or electric flux causes the inducing of displacement current there. So here 1 is the correct answer. Next question. A conducting circular loop is placed in a uniform magnetic field B is equal to 50 millitesla with its plane perpendicular to the magnetic field. The radius of the loop is made to shrink at a constant rate of 1 millimeter per second. Radius is shrinking. At the instant the radius of the loop is 4 centimeter, the induced EMF in the loop is. So induced EMF in the loop you have to find out. So it's given here. EMF E is equal to N d phi by dt only, and phi is equal to B into, so it's kept perpendicular only, so B into area is a pi r square. Radius is given. Now here radius is changing is given, so you have to find d phi by dt like this. B is constant, pi is constant, r square if you differentiate, d by dt of r square should be. So this will be, r square become 2 pi r, So B times 2 pi r times dr by dt is d phi by dt. B is a constant, so r square if you did 2r is coming, then r is again function of time, so dr by dt. Now in this equation, this is equal to, so n number of turns. How much is there? B, okay, number of turns is mentioned, so it's 1 only, you can take it, times d phi by dt is given, B times 2 pi r. B is how much? 50 millitesla, so 50 times 10 raised to minus 3 times 2 pi r is there, so 2 into pi into r, the radius. How much is the radius? 4 centimeter, so that is 4 times 10 raised to minus 2 into dr by dt. Dr by dt means rate of change of radius is given 1 millimeter per second, so that is 1 into 10 raised to minus 3. It should convert to meter. So if you do it, it will become 2 into 50, that's 100, 10 raised to 2 is there, 10 raised to minus 3 is there, then 4 is there, times 10 raised to minus 5 into pi. So this will be, in terms of pi is the answer there. So 4 pi times 10 raised to minus 3 minus 5 is minus 8 plus 2, 10 raised to minus 6 that much volt will be the EMF. So 4 pi into 10 to the minus 6. That's the answer is 4 pi microvolt will be the answer. So here option C is the correct answer. Hope you got it. So here the ratio, rate of change of flux means that is in this way. Let's go for the next question. The primary and secondary coils of a transformer has 500 turns and 5000 turns respectively. The primary coil is connected to an AC source of 220 volt 50 Hz. The output across the secondary coil will be, so secondary coil output we have to find out. We know across transformer Vp by Vs is equal to Np by Ns. Voltage and number of turns relation. We have to find the output across. In voltage will be, so Vs will be equal to Vp into Ns by Np. Vs is equal to Vp into Ns by Np. So how much is Vp is given? See, primary the voltage is 220 is times Ns number of turns in secondary is given how much? 5000 turns is there. So it is 5000 divided by Np number of turns in is there 500 is there. So this will be equal to, if you divide into, be 100, 200, 2200 will be there. So this answer is C. 2200 volt 50 Hertz will be the output of the transformer. So ratio of voltage across primary and secondary will be equal to number of turns in primary and secondary. Let's go for the next question. Which of the following quantity or quantities remain same in primary and secondary coils of an ideal transformer? In an ideal transformer, which of the terms are constant is given? Okay, current, voltage, power, magnetic flux is mentioned. So ideal transformer, you know, whatever the magnetic flux produced by primary will be passing through the secondary also. So only then mutual inductance happens, sir. You know, so it will be constant, you know, and ideal, of course, power also will be constant, but current and voltage changes. Yes or no? Step up and step down we have. So voltage and current will be changing. So answer is magnetic flux and power both. D is the correct answer. For ideal transformer, no leakage of flux. So flux leakage is 0 for ideal transformer. So magnetic flux to be equal there. And of course power is same, then it is called ideal. The next question. A resistor and an ideal inductor are connected in series to a 100 root 2 volt 50 Hz AC source. When a voltmeter is connected across the resistor or the inductor, it shows the same reading. The reading of the voltmeter is how much? So voltmeter across R is equal to voltmeter across inductor. VR is equal to VL is given. So here the voltage across this one you have to find out. Both are equal is given. VR is equal to VL is given. So the voltmeter reading, how much voltage will be there, that you have to find it. So here is given 100 root 2 volt is the external volt is applied. So V equal to is given 100 root 2 volt. And frequency is given 50 Hertz is given. Now we know if VR is equal to VL, then tan phi, we know the equation, the ratio of this one. Now the net impedance Z will be how much? Root of R square plus XL square will be the net EMF. So we have the net impedance Z is equal to root of R square plus XL square. Then we have the resultant V will be equal to root of VR square plus VL square. Now it's given VR is equal to VL. So of course here this V will be equal to root of 2 times VR square. VR and VL both are equal. So VR is given the applied voltage. How much is there? So V is given here 100 root 2. So VR will be root 2 cancels 100 volt. So across the resistor or inductor it will be 100 volt only. So option B is correct answer. We'll move to the next question. The EMF induced in a coil rotating in a magnetic field does not depend upon. The EMF do not depend upon area of the coil, number of turns, angular speed, resistance of the coil. Which answer? You know, EMF never depends upon resistance of the coil. A similar question we done previous. In all other factors, it depends. N, B, A, omega is the EMF induced. Is it? Magnetic field is there, area of the coil is there, angular frequency also it is there. So here are the few questions from last 3 years MCQs from the board papers in different regions. So my dears, please prepare on this well. It will help you to analyze the level of the question paper as well as a great preparation. So wish you all the best in the upcoming exam.